I know you are familiar with the concept of black holes, but how much about it do you know? Have you ever imagined what will happen if you fell into one? What really are these black holes? To understand black holes, you must first understand the idea of gravity. Space-time is a fundamental concept in physics that combines the three dimensions of space with the fourth dimension of time into a single four-dimensional continuum. According to Albert Einstein's theory of general relativity, gravity is not a force between masses, as described by Newton, but rather the result of mass warping or curving the fabric of space-time. Massive objects, such as planets or stars, create a distortion in space-time, influencing the motion of other objects. Black holes form from massive stars undergoing gravitational collapse. When such a star exhausts its nuclear fuel, gravity causes the core to collapse, leading to a supernova explosion. This causes huge mass to come close together to create something so dense. Imagine a mass 5 times to that of a sun being compressed to a diameter of 25 kilometers. The result is the formation of a singularity, a point of infinite density. Simultaneously, the intense gravitational field creates an event horizon, beyond which nothing, not even light, can escape. This boundary defines the black hole. But don't let the name black hole fool you into thinking it is a hole with nothing. It is a huge amount of matter packed into a very small space. Black holes can't be seen as light itself can't escape its gravity, but their border called event horizon are the ones visible. When one enters the event horizon, all the scientific laws known to us stop applying. Black holes have matter orbiting around the event at higher speeds, probably half to that of light. This makes the event horizon act as a mirror, as one will be able to see himself as light travels round back to his eyes. This is due to the fact that the gravity around this black holes are so massive that light is also made to rotate around it. From an external observer's perspective, it appears as if time for you starts slowing down and ultimately freezes. You become a fixed image on the horizon, never quite reaching it. This phenomenon is known as time dilation, a consequence of the extreme gravitational field, and if by any chance you get out of this event horizon, you'll find the world many years far ahead in time from where you left. Basically, you'll have traveled into the future. As you cross the event horizon of a black hole, the consequences are both mysterious and profound. Here the escape becomes impossible due to the overwhelming gravitational pull. Once you pass this point, your fate is sealed. For you, entering the black hole is a one-way journey toward the singularity, a point of infinite density at the core. The tidal forces become increasingly intense, stretching and distorting your body, a process known as spaghettification, until you are eventually torn apart. This is because your feet are close to the black hole than your head, so they feel a much stronger gravitational pull. This effect intensifies as you go further into the black hole until you are an equivalent of a long string, or rather a spaghetti. However, this may not be the case when you go through supermassive black holes, located at the center of many galaxies that have millions or even billions of times the mass of our Sun. If you were to approach the event horizon of a supermassive black hole without getting torn apart by tidal forces, you might not experience the extreme gravitational effects as dramatically as with smaller black holes. The event horizon size in a supermassive black hole is more extensive, leading to a less intense tidal force at the horizon. This may mean it is possible for one to cross through the event horizon successfully. Stephen Hawking proposed that black holes are not entirely black, but emit a faint radiation due to quantum effects near the event horizon. According to quantum mechanics, particle-antiparticle pairs are constantly popping in and out of existence near the event horizon. If one of these particles falls into the black hole while the other escapes, it creates Hawking radiation. Over time, this process results in the slow evaporation of the black hole. However, this evaporation could take place to up to 1,080 years for a black hole to disappear. So are you now ready to park up your suitcase and take a journey into the black hole? Tell me in the comments and I'll surely get back to you.